Hi everyone. Here we will learn the concept of finite automata as output generators. Before this we have seen the concept of finite automata as language recognizer in terms of DFA, or we can say in terms of NFA, or in terms of epsilon NFA. These are language recognizer, means if any language to get accepted, for that we can design DFA, NFA or epsilon NFA. In this case we are not going to recognize the language, and that's why it is called as the output generators, because these kind of automatas are going to generate output. To understand this concept, let's take one simple example. Suppose Q0 is a state, as a starting state, Q0 reading some symbol going to state Q1, Q1 reading some symbol going to state Q0, Q0 having one self loop for symbol A, Q1 having some self loop for symbol B, Q0 reading B and going to Q1, Q1 reading A going to Q0. This is behavior of deterministic, except I have not mentioned here final state. Let me explain you reason behind it. Q0 reading A, Q0 reading B. How we can define output generators? Let's assume that Q0 is a state reading A. At the same time creating the output 0. How you can read this? Q0 state reading A giving output 0. Similarly, Q0 state reading B giving output 1 going to state Q1. Once again, one more example. Q1 is a state reading B giving output 1 going to state Q1. At this moment you need not to worry why output 0, why output 1. This is just example to understand the concept of output generators. So Q1 reading B giving output 1 going to state Q1. Similarly, Q1 is a state reading A giving output 0 going to state Q0. As here this automata is giving the output at the same time when it's read the input. Q0 reading A and giving the output 0 at the same time. So in this case of output generators automatas, there is no final state which was present in terms of DFA, NFA and epsilon NFA. Finite automata as language recognizer. In that case, finite automata final state was present, but here as the output generators final state is not required, hence it is not present. Then how we can define this? There are two scenarios. Here output is associated with input. Here output is associated with input. Similarly, there is another possibility. Let me show you that one also. For example, Q0 is a state. This Q0 state contains or associated with the output. I can say like this. Q0 is associated with output. For example, here what is input? A is the input. What is 0? 0 is output. Similarly, also here I can explain what is B here. B is what? Input. What is 1? 1 as output. Same here. B is input, first symbol. And what is the next symbol? That is the output. Same is here also. But here what is Q0? Q0 is state. State is associated with output. Let me draw this diagram. Then Q1 is a state associated with output. Q0 reading B, for example, going to state Q1 giving output 1, or this Q0 having the self loop for transition A, this is for transition B and giving the output reading input A transition. What's the change between these two diagrams? Here input is associated with output, here state is associated with output. That's the only change. But if we read it clearly, Q0 reading A giving output 0 going to state Q0. Q0 reading A giving output 0 itself going to state Q0. So all the transitions coming to Q0 will give the output 0. For example, Q1 reading A going to Q0, output is 0. For example, Q1 reading A going to Q0, output is 0. So there are two variations: output associated with input, output associated with state. How it can be defined? Let's see the formal definition of this. M is a finite automata as the output generators. What it consists of? It consists of capital Q, set of states. What are the set of states in this example? Q0, Q1. Sigma transition function, it's a set of input symbols. You can say A comma B. Delta transition function. As I told you, it follows the behavior of deterministic. All the states reading input, for example AB, going to one state. Q0 is a starting state. We know this. In both the examples, Q0 is a starting state. Now there are two different terms. One is a lambda, another is a O, capital O. Lambda is the output or machine function and O is a set of output symbols. What are the output symbols here? For example, 1 is the output symbol, 0 is the output symbol, here also 0 and 1. So this O consists of, here in this example, 0 and 1. 0 and 1 is the output symbol, A and B are the input symbols. Then output or machine function, how it can be defined? This can be defined in two ways. The first way I will write here. What happened here? It's the output function. Here output is associated with input. Means what? State reading some input and giving the output. For example, Q0 is a state reading input. Q0 is a state means what? Q0 belongs to set of state. Reading some input A or B. So reading some input and then giving the output. Output is what? 0 or 1. 0 or 1 is part of capital O, set of output symbols. It means what? Lambda consists of set of states reading some input, maybe A, B, something like that, reading some input and giving the output. Similarly, if I define this lambda in another way, in this example, here states associated with the output, there is no need of any input at this moment in this example. So this is the state Q0, Q1 state. So this is the capital Q. It's directly give you output. What are the transitions coming to Q0? It will give the output 0. Transitions coming to Q1, it will give the output 1. So states are associated with output. So these are the differences here. The first kind of example is called as a Mealy Machine. And second type of automatas are called as a Mealy Machine. Whenever input and output together, or I can say output associated with input, in this case it is called as a Mealy Machine. When output is associated with state, for example here, it is called as a Mealy Machine. And this is a formal definition of both. Where is the difference? Difference in terms of lambda, or I can say output function or machine function. And these are the differences here. These differences will define you what is Mealy Machine and what is a Mealy Machine. And these are called as the output generators. In the next few examples, we will see all variety of questions that can be asked on designing of the Mealy Machine and Mealy Machine. Thank you for watching.